Deadlocks. Deadlock is a set of blocked processes, each holding a resource and waiting a resource held by another process in the set. For example, so if there are two disk drives and there are two processes, let us take as P1 and P2. So P1 is holding one disk and it is waiting for the another disk. P2 is holding the second disk and it is waiting for the first disk to complete its task. So unless P1 acquires both the disk drives, it cannot complete its task. Similarly, so P2 also requires both the disk drives to complete its task. So unless one process releases, so any one of the process releases the disk, so both the processes cannot complete their task. So now the both process will enter into the deadlock situation. So what are the different types of resources available in the system? So commonly the CPU cycles, memory space, IO devices, so are the resources in the system. And each resource so will have certain number of instances. So let us take printer as the resource. So we may have 5 printers, then we call it as printer as the resource type, and so 5 is the number of instances of that resource type. So in the normal situation, the system model works with 3-step process for resource utilization. Request, use and release. So request, when the process requests for a resource, if the request cannot be granted immediately, then the process enters into waiting state. So when the resource is available, the request will be granted by the operating system. So when the resource is granted, then the second step, so the process operates on the resource. So that is using the resource. So on completion of usage of the resource, the process releases the resource. So to form a deadlock situation, the following 4 conditions must be satisfied by the scenario. So mutual exclusion, hold and wait, no preemption, circular wait. So mutual exclusion means at least one resource in the set of resources available should be on non-shareable mode. So that means a resource cannot be shared by another process simultaneously. So hold and wait, a process is holding at least one resource and it is waiting for additional resources to get the it's waiting to acquire additional resources, so which is held by some other process. So no preemption is, the resources cannot be preempted. So meaning, resources cannot be taken forcibly. Resources cannot be released forcibly. After completion of the task, the process voluntarily releases the resource. Circular wait. So if there exists a set of processes, so let us take P0, P1, P2 and so on, Pn, and so P0 is waiting for the resource which is held by P1, so P1 is waiting for the resource which is held by P2 and so on. So Pn-1 is waiting for the resource which is held by Pn, and Pn is waiting for the resource which is held by P0. So that is a circular wait. So these 4 conditions are not independent conditions. So for example, circular wait implies hold and wait.